Good evening to all of you. I welcome on behalf of RVSKVV Gwalior, MP, Madhya Pradesh and IDP Naheb to Honorable Vice Chancellor Professor S.K. Rao Sir, Dean Faculty of Agriculture, Directorate Research Services, Directorate Extension Services, Directorate Instruction, all HODs and faculty members of various college and student for these online lectures. As we know, today we have our guest speaker, Dr. Ravi Prabhu, Director Innovation, Investment and Impact, CIFOR, ICRAF, Nairobi, Kenya. Today's topic, farmer can sustainability deliver more than food towards a multiple benefit transformation of Indian agriculture with trees. I request our chief guest, Dr. S.K. Rao sir, for his chief guest remarks and presidential address. Please, sir.
నేను తర్వాత మాట్లాడతాను సార్. Good afternoon to everyone.
Good afternoon, sir.
The Dean Faculty of Agriculture and the Director of Research Services and the Director of Extension Services and the distinguished faculty of the RVSKVB Gwalior and the media students. And it is a good opportunity for all of us to listen today our guest speaker, Dr. Ravi Prabhu, who is an eminent scientist and now working as the Director of Innovations and Investment Impact in CIFOR and ICRAF, Nairobi, Kenya, and he will be delivering a lecture on farmers can sustainably deliver more than the food through agroforestry systems and towards multiple benefits, transforming the Indian agriculture. It is a very important topic. It is a novel topic. How the trees can contribute to the sustainability in the farming systems today, and it will be very interesting, and all the faculty and the students will get the benefit out of that. Sir, I would like to thank you for accepting our invitation and going to deliver a lecture today. Thank you very much, and we can start with the presentation, sir. Dr. Ravi.
Thank you very much, Vice Chancellor Rao, and thank you very much for all the kind words of invitation. It's a real honor to be here. As I start my presentation, I will switch off my camera so that I don't take up too much bandwidth. The last time I tried this, the internet let me down and I ended up having to stop. So thank you very much for being patient with me. Do feel free to interrupt if I go too fast or something's not clear. The intention is to provoke some discussions. After all, at a university, that is the most important thing, that we can examine issues. So let me now try to share my screen, and I'll switch off my camera in the meanwhile. I trust you can see my screen. The topic has already been mentioned. Really what we're trying to say is agriculture or farming can do much more. It does much more than it does today and needs to get credit for it. So the key points, and if you go to sleep after this slide, that's fine, because I would have made my points. Agriculture, as it is practiced, so-called modern agriculture, consumes far too much. 90% of all fresh water in India is consumed by agriculture. Much of the fertile soil, roughly about 20 to 30% of Indian soils, are no longer responsive to fertilizer because they are suffering from degradation, salination, loss of soil organic carbon. So as we produce food, my central thesis would be, we simply cannot focus just on food production. We have to do much more than that. We have to look after water, we have to look at biodiversity, the well-being of the farmers, etc. So that leads me to my second point, which will be throughout the lecture, is that we need to reimagine the kind of agriculture we need here in India. And I will say and show that this is possible using agroecological principles and new technologies, and I will speak about these, to develop the kind of agriculture that satisfies multiple objectives, that is, much more than just food production, to ecosystem services and well being. But if this is to happen, we must treat farmers as equal partners because they are the stewards of the land, they are the innovators, they are the ones who are delivering the work. So the tendency we've had is to treat the farmers as people that you talk down to, they must receive the technology and just do as told. But I think we are realizing that we need to have a different relationship with farmers. And since we are talking within a university setting, let me state very clearly that science must be transformative. It cannot simply be applied or adaptive, it must be transformative. It is our role and duty as academics to explore how a new agriculture can be developed and delivered soon. The status quo, what we have at the moment, is not an option. I hope I will show you that we can be optimistic. And my intention today is to spark your curiosity and your ambitions to start a conversation on a number of issues that I'm raising. So the presentation will be in 4 simple parts. I will briefly talk about how things stand now. Most of you know this, so that may be a little bit boring. Please bear with me. I will speak about why I think there are reasons for hope, the kinds of knowledge, the kinds of approaches, and the kinds of technologies that are available. And then I'll try and bring this all together to make it work towards a transformative agenda and finish with some conclusions. So how do things stand now? Well, we are heading into a number of global food and nutrition crises. And, as an agriculture faculty, you know all about this. There are more people on Earth consuming far more than people in the past did, with a massive impact on the globe. As many of you know, the COVID-19 crisis that we have, the present pandemic, or whether you deal with this one or avian flu or swine flu or any of these, all have to do with the way agriculture and natural resources are managed. This is just some examples. So these trends seem to be worsening, and food systems are definitely at risk. And there's lots of information about this, and I'm not going to go into any of these details. The presentation is available with you, so you can look at it. One of the biggest impacts is the degradation of soil, which is the basis for everything. And you can see just by the amount of orange and red in this map how much soil degradation we're looking at right across the world. And this might actually be an underestimate from some of the more recent analysis that I have seen our people do, especially for India. And of course, we know all about the pandemic. So since 2020, we anticipate that there is about 33% more people around the world in a food crisis. And the number of undernourished people goes up. In India, in fact, the recent headlines, you must have seen it in the last year, the number of the malnutrition has gone up, thanks largely to the pandemic, but a number of other structural issues of getting nutrition to those who need it most have turned up. So we're going backwards. The challenge for us as scientists is that we must not reinforce what are called lock-ins, that you're locking in to technologies that may have worked, may have served us well in the past, but do not serve us any longer. We must plug the gap between the rhetoric calling for transformation and action to enable it. So we are part of the problem if we're not solving the problem. Climate change, all of you are aware, of the contributions of agriculture and soils to the greenhouse gas emissions, carbon dioxide, NOx, methane. There's a huge and land use change and forestry. Land degradation now affects over 40% of the Earth's surface, and much of that is due to bad agricultural practices. If we just take a look at one indicator, it's a favorite indicator of mine, because I work for the Center for International Forestry Research and the International Center for Research in Agroforestry, or World Agroforestry, both centers looking at trees, is the average number of trees per person. This is 2015 data, so it's a bit old. But you can see that even China, with a population comparable to ours, has about 5 times the numbers of trees that we have per capita. And that's a really good indicator that something is wrong with our system. We don't have to get to Canada's levels or even Brazil's level, but we certainly need to be better than China on this. All of us know that the kind of agriculture we practice right now, the intensive agriculture, especially the kind of agriculture we see in the Ganga Basin, Ganga Jamuna Basin, so from Haryana, Punjab, flowing along all the way of the Ganga, is highly intensive. And what it's doing is pumping heavy metals into the soil crop systems and therefore into our food chains. And this is clearly something that we cannot continue to do if we are going to produce nutritious food for people. I think you're all aware that the groundwater depletion has resulted in a massive arsenic toxicity in number of the systems, both in the north, but also in Andhra Pradesh in the south, where groundwater is now pumping, is now 100, 200 meters below surface. The majority of our rivers, where are the sources of our irrigation, are highly polluted, not just because of agriculture, but also because of industry pumping into it. But agriculture does contribute to this. So let's just step out of this, and this is some work that we did a couple of years ago in a small village called Yerraborapalli in Andhra Pradesh. This is a sort of a dry area, and all of these will be very familiar to you. So I'm not going to spend too much time. 10 years back, the situation, even 10 years back, we're not talking about 20, 40, 50, 100 years back, 10 years back, this was the situation. Each family in that small village had 10 to 20 cows, but buffaloes were there. Their sense, and this is farmer recall, so it might be slightly off, that rains were regular and so were the crops. They did not feel the need to purchase fodder for their animals from outside. Their 50 open wells were all functional, and their common grazing lands were available. I've skipped the present because the present is pretty bad, but what's important is 10 years from now, because as research, we cannot fix a situation immediately. We're always looking into the future, 3, 5, 10 years. This is the situation that they are seeing, that their children won't be engaging in agriculture. In fact, there were no young people left in that village. I'm not talking about children, I'm talking about people in their 20s and 30s. They'd all gone to the cities to work as casual labor, etc. They were seeing problems with their drinking water. They were seeing problems with their cattle because they had none or very few. But they were also hopeful that if agriculture could be made viable, their village, their families could also be viable. So what are the reasons for hope? Well, our understanding of ecosystems, and particularly agricultural ecosystem or agroecosystems, is much, much better now. This simple graphic shows you that what is the essence of my talk today. In the top picture, we see largely a monoculture landscape. The second picture shows a little bit more diversity, and the third picture shows more diversity. These are unfortunately European pictures, but if you look at the diagrams to the right, you will see that you can actually get crop production, water quality regulation, carbon sequestration, climate air quality, wood fiber production, all from the same landscape if you plan and manage the landscape differently. So and I speak from a perspective of trees, so we know how to understand, we understand now how to get the best from trees and ecosystem services in agricultural landscapes for the people in those landscapes if we plan and invest and manage accordingly. And that is what I'm going to be speaking about. A few years ago, the Food and Agriculture Organization of the United Nations, FAO, organized its first agroecology conference. And since then, in the 6 or 7 years since, the topic has really picked up. But this was then, and I was there for the conference. And here are just three of the many, many bullet points that we agreed on at the conference. That addressing global challenges in achieving food and nutrition security through agroecology could be achieved by reintroducing biological complexity. On the right-hand side, the top picture is a wheat walnut farm in France with full mechanization. We see this around Yamunanagar, where you've got popular wheat systems. There are many ways of getting complexity back into the landscape. The bottom picture reflects something that is more common in tropical regions, where we have multi-species, mixed strata agroforests, which produce a number of goods and services at the same time. So what this tells us is that caring for the environment can be a means to achieve other goals, not just an afterthought, and there are win-win opportunities to close both the yield gaps and environmental gaps. There's much more understanding now on agroecology. I will not go through all of these details here about the science of agroecology. You can see there are links here, and I would urge you to start looking into them. Both as a science, the kinds of principles it uses, the integrative and systemic approaches it offers, for an agronomy that leads to sustainable development. All of this is going to require us to innovate, and that really is the whole purpose of science, is to take knowledge and develop novelty. Novelty means new ideas, new technologies, new markets and institutions. And the efforts in agroecology is essentially to look at that. But it's also an effort to look at local contexts, because complexity matters, diversity matters. We have tried too long to simplify our agricultural landscapes. If you go back to traditional agriculture, which may not have had the advantage of the kind of science and tools that we have today, but did have the advantage of thousands, if not tens of thousands of years of trial and error, it was about managing a diverse and resilient system. With today's tools, technologies, and knowledge, we can do better and manage those kinds of diverse and resilient systems even better than our forefathers used to. We do not need to go to the rather simple systems that we've had. So one of the three key points in this, and one of them I've just spoken about, is about embracing complexity rather than looking for simplicity. We must enable integration, that all the life forms in the system must work in synergy with each other. I'll come back to this. And on the social side, we need a level playing field. We need to address the market failures, reform policies that are poorly adapted or maladapted, and we need to improve the evidence base. So I'm not going to spend much time on this about why the agroecology movement and agroecology science is picking up. There is a lot of reasons for it, and it is picking up very, very fast around the world. What this tells us, and this was sort of an earlier point I made, is that we need not only new ways of seeing and imagining, we need a new way of measuring. The kinds of measures that we have traditionally used to see whether somebody is doing a good job, which is basically yield per hectare for a particular crop, is not enough. And this slide speaks to the different kinds of measures at different kinds of levels in the system that we might use to get a much better sense of, is that system being managed optimally for multiple benefits, including food production. Let me give you an example of a different kind of a metric. We talk generally about sustained yield. Here we're talking about land equivalence ratios. It is about how much you get from a piece of land rather than a crop. And by a land equivalent ratio of over 1.9, which is what I've had in the previous slide, what you're seeing here is that we're getting twice as much out of that piece of land as when we would have it under monocrop. And this is, in this case, a maize teak system, um, like the wheat walnut system that I showed earlier. So you can double the productivity of land. The individual crop might have a slightly lower productivity, but overall we're getting much more out of the land. This is a rather more complex way of looking at that, where you can bring in other factors into the calculation of the land equivalence. In general, agroforestry, the science that we deal with, pushes the land equivalence ratios out compared to either agriculture and forestry, because it takes the best of both and optimizes. So what this means is there may be landscapes, productive landscapes, where you may, on some occasions, and actually it's not true of India anywhere that I know of, you may want to reduce tree cover in forests and add some agriculture. But by and large, you want to add tree cover to agriculture so that you get much more out of the system. So agroforestry, and I don't think I need to spend too much time on it, is the integration of trees on farms and in the agricultural landscape. It is much more than that. It is about a dynamic and ecologically based natural resource management system, which delivers a whole lot of services and goods that can help us to meet the SDGs. And again, all of these slides are with you, so I will not go through them in any detail here, but I can come back to them in questions. Here are on the left-hand side and the right-hand side, just two examples of different kinds of agroforestry systems. These are both from Brazil. One a bit more simple to start off with, the other already complex to start off with. And what you have then is a very highly productive system. You can just see that, when you start, you're not using the vertical space as much, but by the time you finish, you're using the vertical growing space from 20 to 30 meters above ground to up to 10 meters below ground, whereas previously it was 1 to 2 meters above ground and about 30 centimeters below ground. So the resource use is much, much more effective. And the synergies amongst those plants is much more effective as well. We have seen now this, across Southeast Asia. I think this picture is from Bangladesh. This is a book that we wrote together with FAO. A landscape which usually did not have trees in it, paddy rice, they are now including it. Why? Because farmers are seeing more resilient incomes and more resilient productivity when you mix rice and in this case, mango trees. But you have to manage the mango trees so that they don't produce too much shade. So you manage the canopy, but then people get benefits out of this. And there are many, many examples. These are the simpler systems with just two species here, an annual crop and a tree crop, but you can have multiple species. Here's an example that is a particular favorite of mine. It is, in this case, from the Sahel. It speaks to the what's called the optimum tree density hypothesis. In the middle picture, you can see that by an optimal tree cover, you have the best water use, so best water harvesting out of the system compared to bare land or densely treed land. So if you take areas where you want to practice agriculture, and it's dry, such as lots of northern India and western India, you could apply this kind of a hypothesis to get to just using trees to optimize in the landscape. Let me come back to soil. And as we all know, 95% of our food is dependent on the soil, and I'll remind percent of the earth's soil is degraded. Here's some work that we have done. This comes out of Southern Africa. This is a landscape in Southern Africa, where with tools that we have and which we've transferred this technology to the Indian Institute of Soil Science as well, we can remotely sense a number of soil functional properties. This is that same landscape using our tools to look for erosion hotspots. So we can use this technology over vast areas to identify um, these are maps on the right hand side with the brown is how we remotely sense soil organic carbon to 30 centimeters in soils, and give us much more differentiated and useful mapping of soil properties than on the left hand side, which is sort of an old pedological map that you would be quite used to seeing. Soil organic carbon is very important. This is sort of a map from Tanzania that we have done, because a lot of soil fertility is dependent on this. But if you can improve the sequestration of organic carbon, you are also helping not just the improvement of soil fertility, but obviously you're also sequestering greenhouse gases. And this, I believe, will very shortly will start getting, again, the conversation will start about paying farmers for the ecosystem service of sequestering carbon, something they would want to do anyway for their fertility, but is also a global public good. How did we get about this? I want to speak a little bit about the kinds of technologies that make me hopeful about the future. We use spectroscopy. Traditionally, and I'm sure you do it in Gwalior as well, you would use wet chemistry to do soil analysis. We have pioneered the use of spectroscopy, that is light, mid-infrared and near-infrared, but also X-ray and laser to analyze soils. The advantage of using mid-infrared is that these sensors are based in satellites as well. So once we have the spectral library, this is some examples of the spectral library. We have this for India as well, and it's growing. Then you can fingerprint all the soils in the country, and then you can basically use Landsat, MODIS, Sentinel, or any other satellite which with infrared sensors to start tracking what is happening to soils and mapping that. There's a link here where you can have a look after the presentation to see the kinds of technologies we have. This is one of my colleagues in Nairobi using a mobile mid-infrared device to do soil analysis. It's not just that we do it remotely sensed. We have an approach called the Land Degradation Surveillance Framework, which is also terrestrial. So we really do know what is happening in a particular site. These are 10 by 10 kilometer nested sampling sites. And I think in India, we have at the moment 900 square kilometers of sampling sites, mostly in the southern India. In fact, all of it in southern India, some in the Western Ghats, some in Andhra Pradesh. And the Andhra Pradesh government has asked us to put in another 12 of these sites. So there's going to be more and more of these growing. And we think that by having ground truth analysis such as this of soil functional properties, we can get to the kinds of management of our soils and our agricultural landscapes that will give us the multiple benefits. Here are just some pictures of the kinds of tools that we use. These are all tools used in the pharmaceutical industry, which have been adapted for use in soils. On the left-hand side, that is a robotic machine which can do large numbers of soil sampling. On the right-hand side is a very new X-ray chromatograph, which is mobile. It's like a gun, if you like, which you can use in the field to do field sampling of soils, but also of nutrient properties of the plants. So the key messages from this part, which is quite an important part for me on soils, is that soil infrared spectroscopy is an accurate and low-cost method that is more consistent than wet chemistry because it's completely machine run. And that by building these global databases that we are doing, you have consistent reference analysis and robust field methodologies. We can conduct accurate landscape scale assessments of soil and land health. We're already starting to roll out a similar system for the Indian subcontinent and have been in discussions with NITI Aayog and the Indian Institute of Soil Science and ICAR on this. We think that, this is an opportunity to collaborate and move forward And just to reiterate that ICRAF, we don't usually spell out our acronyms, so it's ICRAF or C4 or World Agroforestry. I'm very keen to work with partners, which is one of the reasons why I accepted your kind invitation. Here's something that we have done for Sri Lanka. This shows change over time in soil organic carbon with our sensors. This is before we've actually put in soil plots. So this we expect to get better. You can see in the 10 years here, the chocolate brown color has become faded. Even in a country like Sri Lanka with high tree cover, they are losing a lot of their soil fertility to erosion and poor agricultural practices. And we had a workshop a few years ago in Sri Lanka, which basically made a change in the way their attitudes to all of this. And that workshop was called "Land Health is National Wealth." But you could also think of it as soil organic carbon is the wealth of the farmer that we lose too easily. This is speaking to the kinds of work that we're doing over there to manage the highlands of Sri Lanka. This is a Green Climate Fund project, which is just starting, using a whole lot of tools to develop the kind of management and agricultural system that I spoke about earlier, that improves productivity, improves the delivery of ecosystem services, and improves the well-being of those who are involved in it by increasing their income and giving them more healthy foods to eat. This is the part where we are managing the water in the landscape because of the hydropower which is being affected. All the reservoirs are silting up in the lowlands. These are reservoirs that are required for both hydropower and for irrigation. And so their water holding capacity is changing. As climate change affects Sri Lanka, we are seeing a shift in the rainy seasons. They have two of them. And shift in intensity as well. So this is climate change adaptation work or ecosystem-based adaptation work that we are doing. I've spoken about soils. You've started hearing me talk about climate action. I think by now everybody can recognize this young lady on the right-hand side. But she's just a representative of the concern that right around the world people have to what's happening to our climate. IPCC says between 8 to 10 years at the maximum we have to reverse what is happening if we are not going to suffer real bad consequences. My message is let's make trees count. Let us use more agroforestry type techniques. Let us bring the diversity back into the agricultural landscapes. Let them look more like the landscapes, of our grandparents than, the fear that we have that our children will inherit a bare landscape. And then we will also be benefiting the climate, which is a key issue for here in India as one of the countries most likely to be affected by climate change in the next decades. Because the hydroclimate and certainly for all the waters that come off the Himalaya, we're already seeing the impact on glaciers and snow melt, but also the climate variability that is affecting the rivers in the north, but also some of them in the south is being affected. So all of this is tied together. This is like a ball of string. You cannot just pull one and hope for the best. Let me talk a little bit about the nutrition side of it, because obviously agriculture is about food and nutrition. If we look at nutrition challenges across the world, you can see that South Asia lags behind WHO recommendations on fruit and vegetable consumption. This is a real problem. And part of that problem is because we do not have the fruit and vegetable any longer in the landscape. We need to basically put the kinds of productive trees in the landscape or horticultural crops that will not only do well under the new conditions, not only deliver more income, but also deliver more nutrition. And this is cutting edge science here. We're talking about using genomics, metabolomics, proteomics in improving the breeding of these species. And I'm not talking here about the popular ones of rice, wheat, maize, soya. I'm talking about a lot of the traditional foods that people have ignored, the millets, the sorghums, the fruit trees, which supply an enormous amount of the nutrition, but have not benefited from advanced breeding techniques. And this is some of the work that we are doing within a program called in Africa called the African Orphan Crops Consortium, which involves companies like Google and LG and a number of others. Uh, People are talking about the game changer that this kind of genomics could be for breeding. We also need to pay attention to the social structures. My conclusion is that you will not be able to get transformative change in landscapes unless you work with people. So in India here, women's help groups, savings groups are one of the key motors for change in the state of Andhra Pradesh, where they're looking at alternative forms of agriculture. So people need to be willing to carry the change, and so that social capital is really important. You can have all the technology in the world, if nobody wants to touch it, nothing's going to happen. So in your curricula, please pay attention to this part of it as well. It's not just about the seeds and breeds, it's also about the people. So let me start winding up and come towards the transformative agenda. This is a food systems approach, a food systems and nested landscapes approach. There's a lot going on in this slide. There is a paper that we're writing on this. But what it basically says is that you need to basically understand your context and have a theory. So that basically means, if you are in Bundelkhand, you have to think differently than if you are in Kerala. If you are in Rajasthan, you have to think differently than when you are in Meghalaya. So have a theory of your place or your context. Have a theory of change. What are the changes you think will happen if you do X, Y, or Z in terms of inputs as they affect the drivers in the system, the food system activities, and the outcomes. And then finally be prepared to change your theory, because what happens might be surprising and you may not be able to explain it. So your theory might be wrong. And so this suggests that kind of a cycle. Because essentially what we're trying to do is move, the traditional way of exploiting natural ecosystems was to move them, to simplify them to traditional farming systems, and then into more even simpler intensified farming systems. And what we are saying is that way we're going to degrade much more land and not meet the multiple benefits agenda that is necessary for the world. So we need to move back upwards to more diverse but still very productive systems. And this speaks about the opportunity here. This is the build up to the climate change conference of the parties in Glasgow later this year. There's a lot going on over here in this space. This is a slide taken from something called Just Rural Transition that we also contribute to. So there's huge momentum moving towards a change in the way we do agriculture. Because I think you will see that the countries have realized they cannot continue business as usual. And by the way, that is also the conclusion here in India, and you might have heard this all the way from the top, from the cabinet, that we need a change in the way agriculture is practiced in India. And this starts speaking to your role as a university. We need to realign the way research development and its deployment is done, so that we can start developing locally and contextually appropriate forms of innovation. So this suggests much more complexity, but actually it also suggests much more resilience and sustainability. Again, I'm not going to spend too much time on the importance of the water, energy, food nexus, and the central role of ecosystem-based adaptation in this. You will have the opportunity to look at these slides on your own. As we try and plan these more complex systems, which are going to be more resilient because of the diversity of species, we have to think about how we deal with climate risk as well. And we have started working on this in the kind of investment planning that ministries or banks or others are doing. And I would urge you to start looking at these kinds of opportunities to push the frontiers of what agricultural science traditionally did and what it can do. This slide just speaks to the importance of governance from the top level right down to in our case panchayat level and village governance. There is often a bit missing in the middle, particularly true in other countries. Perhaps I think in India it's less true, but still it's important to be taken onto account. And again, this is far too detailed for me to speak about the asset-based community-driven approach. It's one of several approaches which are being used now to start delivering this new kind of agricultural transformation that works for farmer well-being. Because if the farmers are not getting more income and more benefits out of the system, then why would they continue to practice that kind of agriculture? And to come back to our role as scientists, it is our role to generate the kinds of evidence that helps decision makers to act, evidence that is rigorous, robust, and systematic. Here again, I'm coming back to the land degradation surveillance framework and the way it does its evidence gathering. There are others, but this is just an example. If we can do this kind of precise quantitative and qualitative mapping based on evidence, here in this case of agroforestry, we have done these kinds of maps in parts of India now and are rolling them across India so that we can identify what species dominate in which landscapes so that they help the planning. Then you can start managing these landscapes for the complexity. This is work we've done together with Kafri in Jhansi. This is actually in Bundelkhand and also now in Odisha, using sort of landscape-based water management techniques, physical structures, but also bringing trees back into the landscape to manage water. This is the example from Odisha, which basically we've looked at hydrological flows across these landscapes, started planting trees, building bunds, etc., so that the entire landscape now, water flows through it, and they're starting to get, second crop and more tree crops in these kinds of. This is the tribal landscape in Odisha. This is work done together with the Odisha government. To come to my conclusions now. We have challenges to overcome with our current systems. I've spoken about it earlier. Lock-in, islands of optimization, something that was good some time ago, and because it was good, it's being perpetuated. Islands where political economy is another lock-in, where people, there is a system, people want to support it, and they continue to support it. Another lock-in is the lack of vision. And finally, the dominance of farm rather than landscape-focused R&D. Let me go back to this so that we don't lose sight. 4 kinds of key lock-ins that we need to break. The idea of a lock-in is to break the lock and enter the room. It doesn't matter if somebody thinks you're a thief or not. Nowadays, we have to break into the room because otherwise we will not survive. So please consider these as important strategic goals to break through. Agroforestry was such a lock-in. It was locked between agriculture and forestry, and together with a number of stakeholders, it was possible in 2014 to push through the National Agroforestry Policy and then the mission, and that has led to a whole number of new investments and new actions. So you can see when you help to create a space where something was locked in before, a lot of innovation, a lot of welfare, and a lot of productivity can result. So much so that the National Agroforestry Policy has now been adopted as an example, and Nepal is picking this up, and we know there are a number of other countries around the world who have in fact come to us to ask whether we can help them to get to their agroforestry policy. So I have made this presentation on behalf of World Agroforestry, also known as ICRAF, and the Center for International Forestry Research, also known as C4. We work in over 40 countries with over 700 staff. We are perhaps the oldest and most globally recognized international research centers on trees and forests and agroforestry in the world. We're headquartered in Nairobi, Kenya, and Bogor, Indonesia. Thank you very much for your attention.
Uh, Thank you very much, Dr. Ravi, sir, for giving your nice presentation and informative lecture on the topic Farmers Sustainability Deliver More Than Foods. Now I request Dr. S.K. Sharma, sir, for giving his concluding remarks and vote of thanks for today's our lecture.
Thank you very much, Mr. Narendra Basure, sir. It was a very brilliant lecture from Dr. Ravi sir. Basically, he was discussing about farmers can sustainably deliver more than food towards a multiple benefits transformations of Indian agriculture with trees. Modern agriculture, as we know, of course, it was for enhancing the productivity or production of the country. But when we adopted this modern agriculture, we forget that we have followed a path of unsustainability. Basically, the green revolution, first green revolution, that was for increasing the production of the country, but we forget what it has done to the sustainability of our ecosystem. What happening due to green revolution or modern agriculture to our lands, what happening to our biodiversity, what happening to the food we eat, and what happening to the biodiversity which is available in the soil. Because of all these reasons, our resources are degrading fast, and now we are under tremendous threat of resource degradation, basically depleting soil fertility, soil degradation, depletion of soil organic carbon, erosion, depleting groundwater, climate change, and of course malnutrition threats. All these things are the burning issues for all of us. And as discussed by Dr. Ravi, that agroforestry is a technique which basically deals with all sorts of problems, and can provide mitigation effects for these problem, especially for climate resilience, by sequestering organic carbon into the soil and also sequestering carbon dioxide into the soil. That kind of very important system, agroforestry system, is required to be adopted at the field level, farmers level. And definitely this tree-based farming system also helps in recharging the groundwater, managing this, maintaining the soil fertility. Basically, it helps in bringing out the nutrients from the lower part of the soil horizon and puts it at the surface, which can be utilized by the traditional agriculture crops. So this way it helps in maintaining the soil fertility. Also, Dr. Ravi Prasad has given very important four factors which are basically locking, or we can say which are locking in the system. Because of that, we are unable to break the plateau which is coming in the productivity in the production of Indian agriculture. These are basically island optimization, lock-in of island optimization, political economy, lack of vision and firm focused R&D. These kind of research on these fields we require, and especially in case of agroforestry, definitely we need it to reach to we need our efforts to direct in such a way so that this system reaches at the farmers level. Even at till today, I think the farmers are not very much benefited with this agroforestry system. Of course, it has appeared as a very successful story from research point of view, but still we have to scale up at farmers level. So with these words, I would like to extend my sincere thanks to Dr. Ravi sir for putting his second efforts for this very important webinar. First time there were technical issues, because of that it was interrupted. Now I extend my sincere thanks to Dr. Ravi sir for taking these pains and delivering this very important lecture. I also extend my sincere thanks to Honorable Vice Chancellor, Professor S.K. Rao sir, who is taking who is present all the time in this kind of activities, and taking keen interest, and he is basically the beacon of light for all of us. I also extend my sincere thanks to OPI of this project, Dr. Akhilesh Singh and Dr. Sudhir Bhadoria, our all the research associate, Mr. Dr. Satendra Kumar, Dr. Avinash Singh, Dr. Bhadoria, Shiv Kumar Bhadoria, and my SRF, Narendra Vasure sir. I also extend my sincere thanks all the administrative officers like Director Research Services, Director Extension Services, Dean Faculty of Agriculture, and Director Instructions of RBSKBB Gwalior for attending this webinar, and also all the faculty members of various component colleges of this university, and also from College of Agriculture Gwalior. I also extend my sincere thanks to all the students who are attending this seminar and getting benefited with this kind of activities of the Vishwavidyalaya. Once again, I extend my sincere thanks to one and all. Thank you very much. Dr. Vasre?
Yes, sir.